So let's answer this question, right? Like, what is factoring, right? Well, maybe in the past, like you guys have maybe made like factor trees for a certain number. So maybe you're like, okay, I got like 32 here, right? And I know that I can take like I don't know, like 8 times 4 to get that. Now that I can split up 8 into 4 times 2, and I can split up 4 into 2 times 2, and I can split up this 4 into 2 times 2, and maybe we've done factor trees like that before. Maybe your teacher has shown you what prime factorization means or something like that, okay? But what factoring means in this sense is, I'll write this, okay? I'll say when we factor a quadratic expression, okay, so again, a quadratic expression, for example, might be, I'll just write one in the corner here. I'll just write this as like x squared plus 7x plus 10. Okay, that's a trinomial. It's quadratic because it's raised to the second power. Okay, it has a degree of 2. So I'll say again, when we factor a quadratic expression, we write it as the product of 2 linear expressions. Okay, so again, I'll maybe underline quadratic expression in red here because I showed it in red over there. And 2 linear expressions, linear expressions are just have an x term, right? So I'll write that again. All this really means linear expression is it has an x term, and that's it. That's the highest degree, is linear, okay? So I can kind of go about and show you like how we do this, right? So really we're trying to split this up, this x squared plus 7x plus 10, we're trying to split this up into 2 binomials with degree of 1, right? So the way I think of this is we have to come up with x squared, right? So first times first has to give us x squared, and really the only reasonable way that we can do that is to have x times x, okay? And last times last has to give us 10, okay? So I did first times first has to give us x squared, last times last has to give us 10. There's really only a couple options that will actually make this work, right? I could do 10 times 1, right? For last times last, I could do 2 times 5, all right? Well, 10 times 1 might not work here. Let's try 2 times 5, right? So I'm going to write plus 2 and a plus 5 here as last times last. And I can actually check this with FOIL to see if I'm correct. All right, what I can do here is right, I'll FOIL this out, right? So I'll get x squared for first times first. For outsides, I'll get plus 5x. For insides, I'll get plus 2x. And then last times last year, I'll get plus 10, right? So when I combine like terms, I get x squared plus 7x plus 10, right? And I'm good to go, right? Well, here is kind of how we're going to set these up, okay? And I want you guys in your notes to draw this big X, okay? And this is how we can figure this out, okay? And I want you guys to write to multiplies to A times C, and I'll tell you what A and C mean in a second here, okay? And I want you to write on the bottom, adds to your B term, okay? And we're gonna write out our certain numbers that we actually get that satisfy those 2 things here. Okay, now, standard form of a quadratic expression is this, ax squared plus bx plus c, okay? So if we look in this case, our a term in this certain example here was 1, right? 1x squared, that was our a term. Okay, our b term here was 7, and our c term here was 10. Okay, so we're basically in this example, we're looking for 2 numbers that multiply to a times c. So multiply to 1 times 10, which is 10, and it adds to our b term. Well, our b term in this case was 7, right? So the 2 numbers that multiply to 10 and add to 7 were 2 and 5, right? And so we just wrote it as x plus 2 and x plus 5, okay? Now I know this may seem confusing, so I'll do the next few examples nice and slowly so again we can all understand them, but this is what factoring a quadratic expression is. Okay, as again we're writing this quadratic expression as the product of 2 linear expressions.